So here we're going to look at graphing functions. So that's kind of recognizing that the x is your x coordinate and then that the d of x, or whatever the function is, that output is your y coordinate. Okay, so those are your ordered pairs. So let's look at a couple of things here. This function is 5x plus 10, where x is the number of units measured in thousands. Okay, and d of x is the cost measured in thousands of dollars. Okay, so just to interpret that, like here the x is 40, well, that's talking about $40,000. So we can still calculate it as a 40, but we just need to remember that that's really a 40,000. Okay, so if I do d of x equals 0, d of 0, that would be 5 times 0 plus 10. So the answer there would be 10, okay? But remember that 10 is really in thousands, okay? So our scale would just need to be as such, where we label it in thousands. All right, now d of 40, that would be 5 times 40 plus 10. So that would be 200 plus 10, so 210,000. All right, and then the 80, similar, d of 80 would be 5 times 80 plus 10, so that would be 400 plus 10, so 410,000. So how much does 40,000 units cost? Well, that would be $210,000, right? Because the d of 40 is 210, so that would be $210,000. How much does 25,500 units cost? Well, that one we would need to do another calculation. What would be our x in this case? Remember, that's thousands for our x value, so that would be 25.5 thousand. So if we plug that in, we would do 5 times 25.5 plus 10, giving us 137.5. So if I make that into thousands of dollars, that would be $137,500. So the thousands in there can all still be worked out, even with decimals. You just kind of got to figure that out. Oh, thousands, so the 1, 2, 3 places to the right for the actual numerical value. All right, so for our graph, let's make sure, right, where that's x in thousands. So that way we can still kind of go out, let's say, let's go out to 100,000. So half would be 50,000, and then kind of split those up into 5 equal places. So each one of those is a 10,000 increment. Now the vertical axis needs to go further, probably more like, let's say 500,000. So 500. And then if I split that up into fifths are sometimes a little tricky, not quite right in the middle, a little above, a little below, and then cut those in half, and that gets you pretty close. So each of those would be 100,000. So let's plot these points, 0, 10. Remember, that's 100, 200, and so on. So the 10,000 would actually be down here, pretty close to the bottom. And then 40,000, that's here, would be 210, so a little above the 200. And then 80 would be out there, 80, and then that would be up to 410,000, so just a little bit above the 400. I think we're looking like that, and those line up pretty good. All right, next slide. So here's a couple algebraic functions. Absolute value, let's just graph that one here on our own before we get to this one with the -3. So the absolute value, let's just make a chart. 0, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of -1, remember, is also 1. And then 2, 2, -2. The absolute value of -2 is 2. So we're actually getting this shape here when I plot the points. 0, 0, 1, 1, -1, 1, 2, 2, -2, 2. You're getting this kind of V shape. So that is actually a pointed V shape. You'll see some in the homework where if you have something like an f of x equals x squared, the graph for that is a little more of a U shape. It's kind of curved. You'll see when you plot the points, it's a little bit curved, so it's not like a straight line coming around. So you'll see some based on that as well. All right, so let's go through an exercise now where we're doing the absolute value of x, but then take away 3 from it. So the absolute value of -2 would be 2, and then 2 take away 3, you get -1. The absolute value of -1 is 1. 1 minus 3 would be -2. 0 minus 3, -3. 1, the absolute value of 1 is 1. Take away 3, we're back to -2. And then the absolute value of 2 is 2. Take away 3, you get -1. So notice our ordered pairs here. Similar calculations to what we did with that V-shaped one above, except this time we've got -2, -1, -1, -2, 0, -3, and so on. So notice this time our V shape, it's the same type of shape as the absolute value above, except it's shifted downward by the 3 units there that we took away. So it's kind of a vertical shift. As you go on to other algebra classes, you'll see some horizontal shifting as well. Kind of has a reverse effect, but that's for kind of down the road. All right, here's one more. This one, remember, if you ever divide by 0, right, that would be undefined. So 1 over 0 is actually undefined. Okay, that's why we have that kind of question mark. There's a point of discontinuity. The others aren't too bad. So if I plug in 2, 1 over 2 would be 1/2. 1 over 1 is 1. And this one here, if I plug in a half, 1 over 1/2 would be the same as 1 times the reciprocal, right? Multiply by the reciprocal, and you get 2. And then divided by 0 is undefined. The others here are pretty similar. If I divide by -1/2, that's multiplying by -2. So we get a -2, and then -1, and then -1/2. So there's kind of some symmetry in those values. So let's plot those points. I'm not putting too many on there because we're going to see most of our picture from here. So 2, 1/2, 1, 1, and then 1/2, 2. So it turns out this graph here, it kind of gets wedged in. It doesn't ever hit that axis because it's undefined at 0, but you kind of get this kind of wedged in shape here. And they call this an asymptote because it'll never actually hit that axis. It kind of heads up towards infinity. And this one also keeps on going and will never go below that axis. And on the other side, -1/2, -2, -1, -1, -2, 1/2. We kind of have that same thing happening here where the graph is kind of wedged in. And like I said, those are called an asymptote. You'll see that a little bit down the road, but it's kind of an interesting graph rather than something being connected. It's like, whoa, it's got these two little parts separated by this point of discontinuity.